Today we're going to complete the square. We're going to look at a visual square, and we're also going to talk about quadratics, which are squares. We've seen three different forms of quadratic functions, and completing the square is a way of going from standard form to vertex form. This is a little friendlier to graph because you can see that vertex right there as HK, which is harder to see when it's in standard form. Okay, a geometry problem. How many yellow tiles are needed to complete the square? Well, when I have 2 green tiles, I need only 1 yellow tile. What if I have 3 green tiles right here? How many yellow tiles would I need in order to form a perfect square? So the perfect square would have to be this entire area right there. How many yellow tiles do I need? And taking a look at this picture, it would form a 3 by 3 down here, so that would be 9 tiles. What if I have 4 on this side and 4 on that side? So 8 tiles. How many individual yellows do I need? Well, I already have 9. How many more do I need? I would need a yellow tile here, 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 and don't forget the corner. So altogether, that is 7 more yellow tiles. And you can play around and see if you can figure out the pattern. So if I've got 12 green tiles, that would be 6 up here. 1, 2, 3, 4, 5, 6, and 6 on the side. So I would form a 6 by 6 down here. That would be 36. Half of 26 is going to be 13, and 13 squared is going to be 169. And that gives us 2,500 here. And this one we could call n divided by 2 parentheses squared. Yep, we're doing algebra. So we're looking at this negative 16 in the middle term, and that half of it is going to be negative 8. 8 squared is a positive 64. Let's do the others. Half of the middle term 6 is going to be 3, and then we're going to square it. So I'll go ahead and write the answers down below. All right, that's the most important step in completing the squares, figuring out what you're missing. Let's take a look at this problem right here where you have a 7 already. I really need 9 tiles here, so I need to add another 2, and that would give me x squared plus 6x plus 9. In other words, x plus 3 parentheses squared. But I can't just add 2 arbitrarily. I also have to subtract in order to balance out the equation. So I'm just going to put a minus 2 with everything, and that way our equation is still equal to this original expression. In other words, I have a perfect square, but I'm missing 2 tiles. So when I do this algebraically, I just make a space. I rewrite the equation, and I put the 20 way over on the left-hand side. I'm thinking in my head, what is half of 8 is 4, and I want to square that. So I'm really trying to get x minus 4 squared, and 4 squared is 16. So I want a 16 right here, but I have to balance out the equation by putting in negative 16. So these first 3 terms give me my perfect square, and then I have to combine the last 2 constants in order to get what remains, which is 4. And there's my perfect square. In other words, I have a perfect square and 4 extra tiles. In order to make this a perfect square, half of negative 18 is negative 9. Squared would be 81. I have to balance that out. These first 3 terms are going to give me x minus 9 parentheses squared. And the last 2 constants are going to give me plus 19.